Hey, this is Satyam here. Can you ask me some of the Python question? Can you react as an interviewer because I just wanna practice my English because I didn't practice my English today, so I wanna practice through the Python here.
Absolutely, Satam. I'd love to help you with that. So I'll ask you some Python questions, and feel free to answer as you like. I'll give you some feedback or follow questions. Ready? Here we go. First question, can you explain what a Python decorator is and give me a simple example of how you'd use one?
I can tell you like what is a Python decorator. So it's a kind of a special function which adds something in the function like in the original function, but it did not change the original function. It adds some behavior, some activity to the like to the main function, like you are doing something before the function and then you are also doing something after the main function, before the main function, after the main function you are just doing some extra work. So that's basically work of the decorator and all. And I have used of example I can give you like a wrapper. We can wrap the original function. So this is how actually things works.
That was a really solid explanation. You kept it clear and you touched on the idea that a decorator is a wrapper function adding behavior. So just to push a bit further, can you walk me through how you would actually code a simple decorator and maybe apply it to a function step by step?
Yeah, basically first I make our decorator like our main function, then you know about that I make a decorator function, then inside that decorator function I create a func function, func which is like we can say a real function which is pointing to the like main function. And after that I create a new function which is like wrapper, like I use a dev keyword, then wrapper, and after that I call I write the like print mm, I am doing some work before the main function, then I call my function. After that I can do the some work after the our function, like which is a print after. So here we have work like three things before, then our main function, then after. So this is the like work. Then when we are calling, then we have to also return the like wrapper. So when we are calling func, it means we are calling our the main function. Okay, so yeah, that's the actually things works.
That was awesome. Yeah, you broke it down really well. You described the structure perfectly, how you define an inner function, the wrapper, and then you return it so it can be used in place of the original. So just to keep it rolling, can you maybe give me a quick example, like a small function, and decorate it and show me what happens when you call it?
Yeah, I know like all these things as I explain you. So can you move to the another question of the Python? I don't want to stick only in this question.
Of course, no problem at all. Let's switch it up. How about this? Can you tell me what a lambda function is in Python and maybe explain a simple use case where it would be useful?
Lambda function, that's very interesting concept. Lambda function is a function like with no name. It's a kind of an anonymous function. It's a small function where we have a like expression and argument. So lambda is a like a small function, and usually we go with the like some of the like operation. We have like some of the function. We have like filter, map, reduce. When we are using these kinds of operation, then we always go with the lambda. So yeah, these are the things that we always like to do with the lambda, like square and then even and odd we find to, about the numbers.
Exactly. That was a great explanation. You nailed it. Yeah, lambdas are really handy for short throwaway functions, especially with things like map or filter. So just to practice a bit more, could you give me a quick example of using a lambda with the map function on a list of numbers, like maybe doubling each number?
I can give you the like example. Let's say we have a list, and list has a like variable which is numbers, and then equal, and in the list we have some numbers like 1 2 3 4. And if you want to use lambda function, then it means we are going to do something here. So we have to find a square here of all the elements that present in the list. So first we will make a variable which is square equals to, then we will write list map, then lambda x, then x asterisk x, then comma, and then number. So then we will print the print. Inside print we are going to write our square, then we will easily get the square of all the number that present in the list.
Perfect. That was a great example. You really explained it well. So yeah, when you apply that lambda inside map, it goes through each element, squares it, and then you get a new list of those squared numbers. Awesome job. If you'd like, I can throw another concept at you. Just let me know.
Yeah, of course. I wanna move to the next concept. You can like ask the another question of the Python.
Sure thing. All right, let's try this one. Can you explain the difference between a shallow copy and a deep copy in Python, and maybe give an example of when you'd use each one?
Hmm. Shallow copy. Shallow copy means shallow copy creates a new outer objects, and its inner object are like still shared. And in the deep copy, it creates a completely independent copy of the object and also its inner objects. And if I want to give example, so shallow copy means if you have a like folder, and you have a folder, and inside that folder you have some papers, and if you are going to create a new folder and you are taking all the same paper inside that new folder, then it's a shallow copy. And if you are talking about the deep copy, then you are like copying all the things here. Okay, in the deep copy you are copying your folder, copying your papers. So it's an independent copy in the deep copy. So that's the actually background theory and concept of the shallow and deep.
That was a really nice analogy. I think it made it super clear. Yeah, exactly. With a shallow copy, you're just copying references, so changes to nested objects still affect the original. But with a deep copy, you get a whole separate, independent structure. Nicely done. If you want, we can do another topic or maybe dive into something like error handling next. Just let me know.
Yeah, in the a deep copy, it's now independent. So when you are going to change in one copy, then you are not going to change the c, you are not going to see the change in the another copy, because now in the deep copy we have an independent copy. And in the shallow copy, when we are changing in any copy, any paper, then of course we are going to see the change in both of the things. So now you can ask me another question which you want to ask me.
Exactly, you got it. That distinction is super important, so nice job. All right, let's switch gears again. How about you explain what a generator is in Python and maybe give a simple example of how you would use one?
Oh, a generator is a function in Python that gives the value one by one instead of giving all at once. It remembers like we have a yield. Yield basically remembers for the next call. So yeah, that's a generator. It generates the value one by one. It gives us the value one by one instead of giving all at once.
Exactly. Yeah, that was a great summary. Generators are super efficient because they produce items lazily, one at a time, so you don't have to load everything into memory. Could you maybe give me a small example, like a generator that yields numbers from 1 to 5, or something like that?
Yeah, I can give example, but for that I have to write a code. And also, can you move to the next question?
Yeah, absolutely. No worries at all. We can skip the code for now. So let's move on. How about this? Can you explain what a context manager is in Python and maybe tell me how you'd use the with statement?
Context manager. Oh, I have never heard about this concept. Can you tell me what is a context manager?
Of course. So, a context manager in Python is basically a way to set up and clean up resources automatically. So, think of it like when you open a file. You want to make sure the file is closed after you're done. The with statement lets you do this cleanly. So you define a context manager like opening a file,
Oh,
and once you're done, it automatically
I
takes care of
got it. I
closing.
got it. What you are actually asking. So you are just saying what is a context to manager. It means when you are opening your file with open your file .txt with a or reading our file and all open, then you have to like close your file. So that's a context manager.
Exactly, you got it. The with statement is the most common example. It ensures that even if something goes wrong inside the block, like an
Hmm.
error, the file still closes properly. So yeah, that's a great example. If you'd like, I can ask you another concept, or if you have questions about this, let me know.
Yeah, you can move to the next question.
Awesome. All right, let's go for another one. How about you explain what a Python list comprehension is, and maybe give me a quick example of how you'd use it to transform a list of numbers?
Hmm. Let's comparison. That's very good concept where we create a list. Like it's a quick way to make a list where we create a list in single line of code. Like we are writing for I in range 5, and you are squaring like squaring with the x x asterisk asterisk then 2, then like using here multiplication sign, and then in one line of code you are like doing your all operations. So that's a quick way to make a list.
Yeah, exactly. That was a great explanation. You just create a new list in one line, often with some kind of transformation, like you said, squaring each number. And it's super concise. If you'd like, we can keep practicing with another concept, or if you feel confident, we can wrap up. Just let me know.
Yeah, I only want to give you the answer of one question. Now can you ask me another question, last question?
Of course. All right, last one. Can you explain what the difference is between Python's args and quargs, and when you would use them?
Hmm. Args and cogs. Basically, args takes like multiple values like tuples. Like we can give the values a, b, like 1, 2, 3, 4, 5, 6. It's depend on you like how many values you want to give. And in the cogs, it likes key value pairs. We gives the data in like key value pairs, and it returns the dictionary.
Exactly. You explained that really well. So args lets you pass a variable number of positional arguments, and quargs lets you pass multiple keyword arguments. And they're super handy when you're not sure how many arguments you'll get. Great job. If you ever want more practice, just let me know.
No, I just don't want to practice now. I want to leave. I want to end this conversation.
Yeah, of course. I'm really glad we got to practice. You did great. So take care, and if you ever want to come back and practice again, I'm here. Have a good one.
Mhm. Okay, thank you.